Welcome to Zero Trust Labs. In this video about dynamic malware analysis, you will learn about executing malware in a sandbox environment. You will learn about various advantages and disadvantages of doing dynamic malware analysis. More than that, in our lab section, you will see the workflow of dynamic malware analysis using a number of tools like Regshot for taking the snapshots before and after the execution, tools like Process Hacker to see the process trees of the running malware processes. Then you will see some advanced tools like Procmon to see all the processes which are running on the system. You can also filter the processes based on its architecture, promise name and other artifacts. All this will come handy in malware analysis process. On top of it, you will also learn how to make graphs of various processes so as to make precise and beautiful malware analysis reports. You will use tool named as ProcDOT for that. After that, we will also learn about Windows event logs, what are the major types of logs, and finally some sexy 6 event logs which are very important during our analysis. We will learn about Sysmon, how we can plot our entire malware activities using a pictorial graph and show it in our malware analysis reports. Finally, we will also learn about some open source tools like VirusTotal for threat hunting and domain tools for knowing who is of the C2C IP address. Stay connected and enjoy the video. Welcome back to our malware analysis series where we are learning malware analysis from very basics. As you must have followed this channel, you have already seen that we have successfully set up a secure malware analysis lab using Flare VM and Remnex. If you have not seen the video, I will attach the link here. Then after that, you must have also seen the video where we performed static analysis on the malware, where without executing the malware, we performed various types of analysis like strings, sections. I will attach the video for static analysis also. In hope to understand dynamic analysis, I request you to watch those earlier videos so that you have a complete understanding of our lab setup and the processes we are following. So, coming back to dynamic malware analysis. Dynamic malware analysis involves executing malware code within a controlled environment and monitoring how it interacts with the system. You remember, in static analysis, we never executed our malware file. We just saw various properties of the file in a passive way without executing it. But here in dynamic analysis, we will go on and actually execute our malware. In such analysis, analysts are able to discover the malware's true intentions and abilities, which are sometimes not visible in static analysis. So, there are various kinds of advantages of malware analysis, dynamic malware analysis over static analysis. In dynamic analysis, we are able to observe the real behavior of malware execution. It helps us in detecting the actual C2s or the IPs or the domains which the malware connects back to. We can also see various kinds of files created or dropped by the malware, registry modifications made, any kind of exfiltration which is done by the malware. You have seen in our static analysis video that we discussed about packed malwares, and there we also decoded one type of packing which was UPX. But some of the times we are not able to decode or unpack our malware. In this case, dynamic analysis comes handy because true nature of the malware is visible only when it is executed. It is useful for analyzing fileless malware or memory-based malwares also. Memory-based malwares are those which do not have any actual file artifact. They are run as a command prompt or a script in memory using tools like CMD or PowerShell. It also captures network indicators like domain, protocol behavior, etc. But dynamic malware analysis has some disadvantage also. Sometimes it may be risky because it requires complete control because we are actually playing with the live malwares here. Our entire lab should be isolated and proof without any leakage or exfiltration. It may be time consuming and resource intensive because in this many times we have to make the dedicated VMs and reset them again and again to know the actual behavior of the malware. Sometimes modern day malwares also detect our sandbox environment like VMs which we make. And in these conditions, they do not execute fully. So we have to tackle those kind of challenges also. Sometimes it becomes difficult to capture all the events or executions by the malware, especially in case of advanced APT malwares. Malware nowadays are smart. They detect the VM environment and delay execution or requires some kind of user interaction to trigger their behavior. We will discuss all these things and see these challenges in real life when we do our lab exercises. But for that, let's first understand the dynamic workflow of dynamic malware analysis. First of all, we will prepare our control lab environment. We have already made a virtual lab, which I showed you in previous videos. We will install the tools and disable the internet. Then we will launch the malware sample. We will execute the file and trigger all the functionalities of the malware. Then after that, we will monitor the behavior of the executable file. For that, we will see number of artifacts like processes, changes in file system, registry changes made, any network activity, any new malware dropped or file created. Then we will collect those logs and artifacts and visualize and analyze them. For that, we may use tools like Sysmon, Procmon, Wireshark, Registry, etc. Then after that, we will analyze and correlate the events to know the actual patterns, IOCs, persistence, lateral movement. These steps are very important for malware analysis to know the complete behavior of the malware. So now let's dive into our lab and play with real malwares. So before directly diving into the lab, we will see various kinds of tools which we will use for dynamic malware analysis. We have installed a number of tools as a part of our Flare VM setup. Apart from that, we will require some other tools which we will download separately. For monitoring and logging, we will use tools like Sysmon, Procmon, Process Explorer, and Process Hacker. They will capture detailed system activities like processes, file registry, and network events. For network analysis tools, we will use tools like Wireshark and Zeek. These are for collection of the PCAP files and analysis of the network traffic. Finally, for visualization and correlations, we will use tools like ProcDOT and SysmonView. They will visualize the relationship between various kinds of events and process trees which are happening when the malware file is executed on the system. So now when everything is ready, now we can dive into our lab and execute our first malware for dynamic analysis. See you in the lab. Welcome back to our lab. Here we have set up our Flare VM with all the tools which we will require for our analysis. We have our malware repository where we have taken all the samples. I have already gone through first 3 sections in the previous video. Here we will be going to do a dynamic analysis of core plug malware. Core plug malware is basically a set of 3 malwares, which is a executable file, a DLL file, and a payload file. Now let's unzip it to get started. You can see here, this is the malware file. We will unzip it using our password infected. You can see here that it consists of 3 files, which is an Avast executable, a DLL file, and a DAT file, which is our payload file. The interesting thing about this set of malware is that it consists of a genuine executable, which is our Avast file. We can go here and see the properties. In the details, you can see that it has a copyright of Avast software. Then we have data signatures for Avast also. After that, we have a malicious DLL. You can see here there is no copyright or signature for this DLL. Then we have a DAT file. Now we will go and execute this malware to see what kind of changes it makes in the system. Before that, I will request you to do static analysis of this malware as a homework for you. Before executing this malware, I would like to introduce you to new tools which we will use in our first stage of analysis. First tool is Rakshot. Rakshot is a utility tool which logs all the changes made by the malware in the specified directories. Here in this we will take the first shot, which will take all the directories and files before we execute the file, and once we execute it we will take the second shot and then compare that what changes have been made by the malware in registry and the file system. Another tool which I would like to introduce is Process Explorer. Now, Process Explorer is a tool which shows all the running processes in the Windows system in a directory-wise manner. It is a tree structure which shows the processes and the sub-processes in a structure which is easy to read and understand. Now, you can see here that various kinds of SVC host processes are running, then a CMD is running, then you can see explorer.exe is also running. You can click the process and right click to see all the properties related to this process, like the image file from where the process has been loaded, the command line which has been passed as an argument to this process. Then you can also see various kinds of strings which are there in the process, then parameters like performance. You can also see any TCP/IP connections which are made by the process using this. Here you can see various security protocols like permissions which are given to the process, etc. and etc. So this was a basic introduction of the tool. Now let's get started and execute our malware file. Before that, we will take the first snapshot of our C directory before executing our malware. It will register all the keys and the values of the current state of the malware. Let's wait for the process to end, and after that we will execute our malware. So now first shot has been taken. It is showing us the details of date and time, username, keys and values which has registered. Now time for us to execute our malware. Here we can see that our core plug malware has 3 components, and we are going to execute it as administrator so that it has full privileges of the system. I have already executed the malware, and I will go to my process tree to see the process which has been started. You can see here at the last that avast SSC process has been already started in the process tree. You can see the properties from here. You can see that it is now running from program data. Remember that I have run my program from a desktop folder, but now you can see here in the current directory in samples I have run my executable, but now it has, so here we can deduce that it has dropped itself in the program data folder. You can see here any other thing which we can go to strings. You can see here there are various kinds of these strings. You can also analyze using static analysis. Also you can see here there is a string named workspace production clients, etc. and etc. Then the digicert. You can look for any intelligence or any important thing which you can find in the string section. It is also showing wsc.dll, which also means that it has loaded this DLL file. Now after this we will go and take the second shot of our rec shot to see and compare the results which the executable has made in the file system. Let's go and take the second shot. You can see here the second shot has also been taken and the details are also mentioned here. Now we will go and click the third option, compare, to see what are the changes which it has made in the file system. For that, click the compare button and wait for the tool to compare and show us the output. Well, you can see here that it shows that 14 keys has been deleted, 7 keys has been added. In terms of value, 36 deleted, 5 added, 43 modified. All these things are the changes which are made by. We can now click on the output button to see a text file which shows all the changes which has been made. So these are the registry changes which have been made. These are the values which have been changed. Now you can see here one important thing in front. In HKLM registry hive, it has entered a current version run, which is a persistent mechanism to run every time for C program data, avast, avsc and avast.exe. You can see there is an entry in HQ registry hive also. And you can see that for our samples path also there is a registry entry. These are the values modified by the malware. You can see these are the files which are deleted. And these are the files which are added or modified. These are all the changes which were made by the malware, and we could easily see them using our utility tool named recshot. To confirm it, we will go in the program data section to see whether the output which our tool is giving is right or not. We will go into program data and we will see that a new folder has been added to this timeline, which is avast avscsca, and it contains all our 3 files which we executed from the desktop. So it is confirmed that our malware has executed and it has entered itself into the Windows file system. Well, Our malware has been doing a number of things. It has dropped itself into the registry, it has created some registry changes, and it has made some new files in the program data as well. To see all the processes in detail, we will use one another very useful utility which is known as Procmon. Procmon is another tool which registers all the changes made by every process in the Windows subsystem. Now, for that, we will again execute the malware so that we have the fresh entries or everything. Remember, our malware is already running, but since we have not started our Procmon before that, so we are starting it again. So our malware has been again started. You can see here that it is showing entries for all the processes like las, explorer.exe, then ctf1.exe. But now we know the process name already from our process hacker tool, and we need to filter all the logs for only the our concerned process. So there is a very good filtration tool or utility available in this tool. Click on this filter button and this dialog box will open in. From here, if you will drop down, you can see that you can filter the processes based on various kinds of things like architecture, command line arguments, date and time, process name, process start. If you know the PID, you can filter out on based on the PIDs as well. You can filter based on relative time of execution as well, then time of day, then user, etc. and etc. So we know the process name, and from here we will select the option process name, and here we can see in the process name our Avast SSC process is listed. Select here and add this. Click apply and click OK. Now you can see in detail what are all the changes which have been made by this Avast SSC process. You can see here various kinds of registry changes which have been made. You can see here it has, I will just drag it so that you can see here. You can see here that it has accessed our malware from our repository, where in from dynamic analysis folder it has loaded this file. Then it has loaded some DLL files like LT and NTDL. Remember the static analysis sections where I told you about Windows API section, which contains of all the Windows based API utilities which are pre-built in the Windows subsystem, and the applications use it so that there is no code duplication and the processes are compact. Now you can see here that it has access C Windows, again the various kind of registry changes. It has created a file in app patch, you can see from here. You can see here that wsc.dll is also loaded, which is also visible from the filtered logs. Now, one more interesting thing. Here you can see that it has also created its footprint in app data roaming intel folder also. This is another thing, but we already saw that it has dropped itself in the program data, which is again visible from these logs. But in roaming intel also it has made its entry. We will confirm it in the file system. One another important feature of this tool is that you can filter your logs based on these filters also. If you don't want to see the registry changes, you can uncheck it from here. If you don't want to see the network changes, you can uncheck here, and there is a there is an option for processes also. Now you can see only the changes which are being made in the file subsystem. It has called some DLL files which is known as which are used for cryptography and encryption, which is also interesting. We will deselect here and see. For now, no network connections has been made by the malware, but we know that some of the malwares have anti-VM evasion techniques, so they don't run when our malware is executed inside the VM. We have way around for that, and I will discuss it in the further video. Now let's go and see our roaming intel. We'll go inside users, John, app data, roaming, intel. So for now, though malware has not made any registry here, we will again come and check if there is an entry for that. You can directly jump to this location from here also. For now, though, no entry has been made, or it may be deleted once the program has been put into program data. This intel roaming is mostly the staging case, so here also there must be only staging of this file for some seconds, and then the file is injected into the program data. Now this was it for using our process monitor Procmon tool. It is a very handy tool you should use. It logs all the processes and all the files load, which gives a very good idea about what the malware or the executable file is actually doing. I will further use this tool to get the logs and visualize the entire process in a very pictorial graph format. But for that, I would like you to try this tool on and run the executable and see what all you can find in your system. Till now, we use RecShot to see what are the changes which were made in the registry and the file system. Then we used a tool named Process Hacker, where we saw a new process named Avast SVC, which was started by the malicious file in the Windows subsystem. We also used the tool named Process Monitor to see what all the changes or the queries which are being made by the executable in the Windows subsystem. We were able to filter it out based on the process or any other artifact which we have. Now, but this is not enough. Now we want to map all these activities in a graphical format which is good for report. For that, we will use another utility which is known as ProcDOT. So what is ProcDOT? ProcDOT takes all the logs from the process monitor and it logs it in a very graphical format which is easy to understand and digest. As a malware researcher or a cybersecurity analyst, it is very important to show our reports in a clear depicted manner so that the upper management or the other stakeholders which need to act upon those reports have a clear understanding of what the executable or the malicious file is doing on the endpoint. So for that, let's get started and to use ProcDOT. For that, go in the options sections. We have to do a small minor changes. You can see here various kinds of columns which are available in this log. Here, if uncheck this sequence number if it is checked in your option, and check on the threat ID. So I have checked both. Now I will go and save these logs as a CSV format so that I can ingest into some other tool name which is named as ProcDOT and process it. Go here, select the option that events current displayed on the current folder so that we can get logs only from this process Avast SVC. Then we will save them in a comma separated format which can be ingested easily. We can select the path whichever we like. I will choose desktop to save these logs. Click OK. Now you can see here my log.csv is ready, and it has all the logs which have been made by Avast SVC process, which we saw in the process monitor tool as well, but here they are in SVC format. You can see here there is a column for time, I think I need to have a subscription for that. No worries, I will open it in Notepad and show you. So here is the columns which are available in the CSV. First is the time of the day, second is process name, third is PID, fourth is the operation, then there is path, result, detail, TID. And these are all the details which are related to the process. Sounds very bulky. Don't worry, we have a tool to ingest it in few seconds to give us a very good report. Now in the Flare VM, ProcDOT comes as pre-installed. We have already installed this tool. Open this tool. Here you can see this window where there are various options to select from. We have Procmon, WinDump or launcher options. Don't worry, I will guide you one by one how to process it. On the three dots along Procmon, select it and select our log CSV file which we have just exported from Procmon. Once you have exported it, then we need to select the launcher. Launcher is basically the process ID which will show us the results. I will full screen that. Now along the launcher, select these three dots. It will show us the three processes which are running. These are running different processes because we have executed our malware files multiple times. In your case, you will execute the malware only once, so there will be only one executable here at in your log files. I will select this and then I will select the refresh button. You can see here it will generate, it will process all those logs and generate a interactable class. Here it is. So we can see here that this was our executable file which was executed with PID 6052. Then it generated its own thread 7136. Then it made a registry entry in the HKLM software hive for current version run so that it can maintain persistence. It also made a registry entry in HKCU which is HKCU registry hive for auto starting. This is the persistence mechanism which is used by the malware. This is the second PID we ran the malware again. So this is another artifact that it dropped itself into C program data Avast location. We will just for our satisfaction choose other launcher also and see if there is any additional information which is available for us. Nothing was visible here. So using the third process also we are able to generate the same graph. So using this tool, how beautifully and in a pictorial manner you are able to show that what the malware file is actually doing. How wonderful is this to show these kind of reports to the senior executives who have limited knowledge and time to understand about what the incident actually happened. So this is a very good tool which you should have in the kitty and you should use more often so that you can generate beautiful reports. Now we will dive into some other topics which are very important for our overall analysis. We have already analyzed the malware, its dynamic nature. In earlier videos, we have already seen the static analysis about strings, about other artifacts, digital signatures, etc. There is one another important part which is very important to cover. Every suspicious click, every login attempt, every stealthy attacker move, Windows subsystem records its all. But unless you know how to read that clues, those logs are just noise. Today we are going to unlock the potential of Windows event logs, break down their structure, uncover various important types of event logs that every malware or SOC analyst must know. And finally, we will see a utility tool known as Sysmon, which is a secret weapon that turns your event data into a high definition crime scene replay. So, what are these Windows event logs? Windows event logs are like a black box on your operating system. They store the structured records of systems, applications, security events, etc. and etc. into EVTX files. They can be seen under directory in C Windows System 32 Win event logs. Basically, it is an inbuilt logging mechanism which has been made in Windows subsystem. They are very important in troubleshooting, finding out why a service failed or an app crashed, for auditing, tracking who did what and when, security monitoring, detecting and investigating any malicious activity or any network connection made from the Windows system. Windows event logs are not random messages. Each log has a consistent structure that makes it machine and human readable. Basically, in Windows Event Viewer, you can see under Windows log directory there are basically these major folders, which are application logs, which contains log about the applications. Then there are system logs, which contains system component events. Then there are security logs, which contains logs like login and log off logs, then file access logs. And then there are application and server logs, which contains various kinds of miscellaneous logs. Structure of these event logs is very important to understand so that we are able to deduce correct information efficiently. Every event record contains multiple data fields. Let's break them down. I have attached this snapshot from my Windows Ever for a sample event log. First of all, there is a log name which tells us the category to which these logs belong. Then there is source, the component or the application that generated it. For example, in my case, it was generated by Microsoft Windows Security Auditing logs. Then there is an event ID. There are various kinds of event IDs which are allocated to these logs. We will see them in further in detail. Then the level, which tells us about the severity of the log, whether it is just for information or it's a warning, an error has occurred or any critical event has occurred. Then there is date and time, when the event was created. Here it is shown in logged section. Then the user who was logged in when this log was generated, the computer name where the log was generated, the description of the log. And then in event data section, there is a raw unstructured XML data. Why it matters? It matters because you can filter on these event logs, export them into XML for parsing, and correlate with other logs to build timelines in your analysis process. In incident response, you cannot monitor every log. If you will try to do so, you will get drowned in tons of data. That's why analysts used 66 approach, focusing on the logs that give the best security bang for your buck. Let's break them down. First of the group is process execution logs, which have an ID of 4688 or 4692. whenever the new process is executed, or in our case a malicious process has been executed, log gets the event ID from this section. Tools like nmap, ssh, process execute, ping.exe or PowerShell are executed, then they get event ID from this section. Then account logged in logs. Whenever a new user has logged in into the system, he gets the login of 4624, event ID of 4624. For failed login, it is 4625. For any system special privilege assigned or usually admin logins, it gets 4672. When a user account gets created, it gets 4720, and when the user accounts get deleted, it gets 4726. Then there are various system event logs also, like for 7036 service state change, 7045 new service installed. These are also important to understand because persistence often comes from malicious services or driver tampering. Then they have particular logs for PowerShell also. For application also there are specified logs. There is a complete documentary for these kinds of logs which are visible on your screen. I will also attach the link to this documentary in the description of the video. Remember, to know majority of these logs, it is very important. By monitoring just these 6 sources, you can cover authentication, persistence, privilege escalation, and command execution without drowning into other irrelevant events. There are various types of logon type also. Logon type basically shows that how the user has logged on into the system. In Windows subsystem, there are various kinds of options of logging into the system. For example, for logon type 2 means logon via console. For logon type 10 means remote interactive logon. Just to give it into perspective, if you see an event ID 4624 with the logon type 10, it surely means the user has logged on using RDP protocol of Windows system. Combination of these also gives us the idea about the attacker actions on the system. Understanding these events logs are not only important for malware analysis, but it will also help you in analyzing other things about the infected or compromised endpoint. That is why it is very important to know about some of the major event logs. One of those category is also known as Sysmon. Sysmon is also known as the security superpower. Sysmon or System Monitor is a part of Microsoft's sysinternal suite. Once installed as a Windows service, Sysmon continuously monitors and logs detailed system activity to the Microsoft Windows Sysmon operational channel. Remember, Sysmon doesn't come installed in the Windows endpoints by default, but we have to install it on our own by downloading it from sysinternals library given by Microsoft. There are various kinds of specific IDs which are allocated to Sysmon as well. Why Sysmon is a game changer? Default Windows logs will give you broad strokes. Sysmon will give you the very fine details. For example, Sysmon event ID 1 is for process creation, which will include the full command line, parent processes, and file hashes of the process which is generated. Similarly, event ID 2 is for file creation and time changes, which will help you to detect time stomping done by the malware file. Then event ID 3 is for network connections. Event ID 6 and 7 is for image or driver loading. There is a full documentation of these logs which is available on this site. Let's open it. You can see this is the official page for Sysmon. There is a brief introduction about Sysmon, how it works, overview of the capabilities of Sysmon, which I have already showed you. Then there is a screenshot where you can see how in fine detail everything is logged. Then there is a there are steps to install Sysmon, various kinds of parameters which can be used in installing Sysmon. Then, in the event section, there is a complete detailed documentation of various kinds of event IDs and their full description. For example, event ID is for create remote threat, which the malware generally uses for process injection by injecting malicious code in the uh, other processes. Then file creation, registry event, etc. and etc. There are number of Sysmon event IDs which you can refer from this section. Now, when in the installation section, you can see that there is a link to install the Sysmon file, and we will download this from the link. It was a 4.6 MB file which was downloaded, and in the installation section you can see that you can usually install it using a command line option, but for that you have to first give a configuration file to this as well. So we will search for configuration file for Sysmon as well. So this is a configuration XML file which contains detail about various kinds of logs and how to map it. We will download this file as well. I will attach the link of this file as well in the video description. We want to keep it. One another utility which we want to download for graphically showing all the Sysmon logs is SysmonView. SysmonView is another utility which takes all the logs and shows it in a graphical format. We will download the zip folder from here. It will contain all the tools which are required. Apart from SysmonView, it has Sysmon shell and Sysmon box also. We will not use these tools in the video. This video will be limited to the use of SysmonView, which itself is a very good tool for graphical representation of all the Sysmon logs which are captured by the Windows system. Since we have downloaded all the three required files for Sysmon, now it's time to take it inside our Windows VM and install it. For that, as I have shown you in my previous videos, we will use shared folders options. We will create a shared folder option here, where we will share our Sysmon files folder so that they can be accessed inside the VM. Open this. In the network section, you can see that our shared folder is visible, which is Sysmon files. I will copy all these files to a new folder on my desktop. I will name it Sysmon and paste all these files here. Now I will extract these files here so that I can download it. I will use 7-zip to extract Sysmon first. Then I will also extract the other folder which contains SysmonView. Although we will require it later, but let's unzip it. I will copy this config file inside the Sysmon folder because we will require it once we install Sysmon. Now, time to install Sysmon. For that, we will open our own very sweet tool, which is PowerShell. Run as administrator. After that, we will go into the directory where we have a Sysmon executable and the config file. Just copy the path from here and paste it here. You can see here both Sysmon and Sysmon config file are here. Now we will go and install the Sysmon tool. You can see here that our Sysmon has been installed and it has already started. Now, time to see these logs. I will close this PowerShell and I will open Event Viewer. As I have mentioned earlier, Event Viewer contains all the logs. In the Windows logs, you can see there are various kinds of logs like application logs, security logs, system logs, forwarding event logs. But our Sysmon logs are in some other location. In the section named as application and server logs, when you drop it down, you will see an option for Microsoft logs. When you click drop down on this, you will see another section which contains Windows logs. Select this also. It will show you various types of miscellaneous logs which are there. In this, go down and look for Sysmon. You can see here these are the Sysmon, and in Sysmon operational section, if you double click, you will see various kinds of Sysmon logs which are being made here. If I will click process created, as I have showed you that it has a Sysmon event ID 1, it has used system, computer name, process creation time, everything is visible. When I go to detail section, it will show me other details about this also. I will just drag it a bit up so that you are able to see. See, normal event logs don't contain this kind of information, but in Sysmon event logs, you will see entire information. You can see the image path, you can see command line, you can see the user, which is John. You can see that the parent image is explorer.exe, etc. and etc. So now, since we have confirmed that our Windows system has started gathering Sysmon logs, we will go and again execute our malware once again. So this was our malware repository. In the sample section, in dynamic analysis section, we have our malware, and we will go again and once execute it. You will see that a new file creation log has been generated. It will create remote thread for a new thread which has been generated using PowerShell. All these logs are there, but one interesting log is also there, which is DNS log. You can see there this event ID makes a DNS query as well, and it has made a query to an IP address which is 103.192.226.100. This is interesting because in our analysis using Procmon, we were not able to see any network connection which was made. I told you that these advanced malwares like PlugX family or ColdPlug, they are able to see anti-VM capabilities and they are able to abide all these. But in Sysmon, these logs are captured. That is why Sysmon is our go-to tool for security purposes. Sysmon turns the blurry picture of an attack into like a 4K replay with slow motion. That is why it is on every blue team's must install list. And for your dynamic analysis, if you're not using Sysmon, start using it. Now, time to move ahead. We have already seen these Sysmon logs which have been generated. Now, time to export these logs. For that, you will see on the right section there is an option Save All Events Logs As. In the desktop, I will name as Sysmon Logs, and I will save the file as XML file. You can save as EVTX file also, but I will save as XML file because I need to ingest it into another graphical representation tool which is known as SysmonView. Click OK. You can see there is a prompt that our logs has been successfully saved. This is the log file. I will again go into Sysmon directory and open Sysmaster tools. In that we will find a tool named as SysmonView. There are two versions for 32-bit and 64-bit. As we are using a 64-bit version of Windows VM, we will use 64-bit version, extract it. Now, this is the SysmonView executable file. We will execute it. It will give us a prompt, say yes. Now, this is the basic outlook of the SysmonView file. From here you can see there is an option of file where we can load existing data, or we can import Sysmon event logs. So we will go and import our Sysmon event logs in an XML file which we have recently generated. It was on desktop. This is our Sysmon logs.xml. Select import and click OK. You can see here that various kinds of Sysmon logs for various processes has been uploaded. The good thing about SysmonView is it has filtered it out or categorized it based on the various kinds of processes. In our analysis, we already saw that the process which was executing it was avast svc.exe. So we will click this. Here you will see the image path, basically the path from where the process is being executed. We saw that we executed our malware file from desktop malware course samples repository, but it also made a entry in program data also. So it has taken both the paths. We will go again and execute both the paths one by one. First, we will execute our desktop path, which from where we executed the malware first. Here you can see that there is a graph which has been generated. Meanwhile, we will generate our graph for the program data location as well. Then we will click that and click this again. Now, this is the complete graph which has been made on this. You can see on the top, this is avast svc.exe file which was executed. This is a computer host name where it was executed. In the first tab, it shows that it created one file, it created one process, then terminated one process and create a registry entry. So you can see here that it generated a parent image explorer.exe. Explorer.exe comes because we executed this file from explorer.exe as well. Then it created another file in the program data which was mentioned here. Then it made a registry entry for persistent which we have already discussed. On the other tab, you can see that it made a DNS query to 103.192.226.100. Another DNS query was made, and the rightmost tab shows that the avast.exe was the process which was executing it. So you can take a snapshot of this and save it for your report purpose. Since it shows all the things in very detail. Now, we already knew these things, but Sysmon has given us a new intelligence that it has a C2 address also, which is 103.192.226.100. So what we will go here, our work doesn't stop here. Now we have a C2 address and we need to know and inquire about the C2 address and report it in our final report which we will make. For that, we will open Chrome and go to a utility name as VirusTotal. VirusTotal, you must all have known, those who are working in security, that it is the Google for C2s and IPs. We will go here and search for our IP address, which is 103 192.192.226.100 and click enter. You can see here that 11 security vendors have already flagged this. This IP is based in Hong Kong. We will see more details about this. You can see this various security vendors has already flagged it malicious. After that, we will go into details in relations to see various kinds of other. You can see here it is related to Sogu plugx. In the community also we can see that there is a Sogu plugx mentioned, then plugx. We can also check who is of the file to see of the IP to see where this IP is actually located. For that we will open domain tools and we will go and copy this IP address here. Yeah, bro, I am not a robot. You can see there is IP is located in Hong Kong. These are the whois details. So it is worthwhile to mention the C2 address on the report as well. These report may go to SOC teams or higher management teams which need to block this IP on the external firewall or create a rule when this IP is triggered. So Sysmon was a very useful tool and it gave us a number of other things which were not visible otherwise. Windows event logs see everything, but it is up to us that how we look into these logs and how we read these stories. I would say that we should start with Sexy 6 for maximum coverage, add Sysmon for clarity, and you will be well ahead in detecting intrusions before they become disasters. If this deep dive has helped you and you have some understanding of dynamic malware analysis also, I would request you to download some malwares of your own and try and analyze them. But be sure that you are in a safe environment. Maintain the security of the lab because here you will be executing live malwares. You may even connect to C2 servers which may be disastrous. So please keep in mind that your lab is secure, you are safe, and you are well within your legal rights to do such kind of activities. Thank you for liking and subscribing to the channel. Please drop a comment if you like the dynamic analysis malware section.